So this is what the deployment request looks like, and it consists of a couple of different pieces. There's a set of nodes. These are a single virtual machine. Each node has a provider, so the provider is like Amazon, and you can have different providers in one deployment. So you could mix Amazon, say, with Magellan, and as long as the VMs can talk to each other and talk to the coordinator, then it will work out. Each node also has some number of plugins. These are the user scripts, and the plugins have parameters that you can pass to them. And then there's dependencies that allow you to say that one VM depends on another. And so this example here creates a simple I think it's a 4-node cluster with one NFS server that exports a file system, and then 3 NFS clients that mount that file system. And so you can pass this off to the coordinator using the command line tool, and it will automatically provision this for you in the cloud. So about dependencies. So this is the dependencies in Wrangler model is a directed acyclic graph. So for example, if you have a Condor pool, you have a Condor master, and then some number of workers that depend on it. Here's an example of a web application that has some web servers, an application server, a cache server that the web servers depend on, and then a database server that the application server depends on. So what the dependencies allow you to do is specify the ordering in which these things should be configured, so that when the Wrangler brings the system up, it knows what order to set things up in. Groups, this is just a trick, if you have a situation where your application is not quite a DAG, where you have mutual dependencies between components, then you can use a group to specify them. I don't want to talk too much about this, but basically some parallel file systems, you require this if nodes are dependent on each other. Plugins, these are the user-defined scripts, and they take these 3 commands. So there's a start command that basically says the start command is passed to the script when the VM is configured by the coordinator, and it tells the script, set up whatever you're going to set up, start whatever services you're going to start, and then exit with a value that tells me that you're okay. Stop is sort of the opposite process, terminate whatever you're doing and clean up. And then status is a monitoring tool. So it'll call status periodically to make sure that the VM is still up and running, and that the plugin role that it implements is still functioning properly. So here's an example deployment. This is similar to the XML document I showed earlier, but this is for a workflow application. So it consists of one submit node. So this is the gray box is a VM, and the blue are the plugins. That has Pegasus, Dagman, and Condor, which are the pieces of Pegasus WMS, and then Condor worker nodes with a Condor plugin, and NFS client plugins that depend on a file server that has NFS server plugin installed on it. And so before I move on to the next topic, I want to say a little bit about dynamic provisioning. So like I said early on, the resource requirements of workflows change over time. And this is an example of a CyberShake workflow. This is an earthquake science application. And it shows, over a one workflow run, the number of jobs that are running and idle. So running is blue and idle is green. So what you can see here is that for this run, 800 cores were provisioned. And so that's sort of the top of this blue line. You see there's spikes, there's peaks and valleys. So there's areas where the resources are fully utilized, and there's idle jobs waiting on, and there's other areas where there's a big valley that the resources are being underutilized. And so over time, the resource utilization of this particular workflow was less than 50%, just because of tails and all these valleys and things. And so really, in the cloud, you really need some tools to allow you to adapt the number of resources dynamically that you're using. This is a problem too in grids if you're doing pilot jobs or things like that. But this is very much a research topic, and we're working on some algorithms for doing this kind of thing. In web applications, for example, you might find this is auto-scaling, right? So auto-scaling is based on maybe a response time of the web server. And so that's the system knows to add more web servers when the response time gets too high. So you need something similar to that for workflow applications and other science applications we deploy in the cloud.